class sessions left, 4 instruction sessions left, which is good and bad in a way, because it is good because it's finally out of your hair, right? It's kind of bad for me because I still have a lot of topics to go over so that you guys will be ready for your next class. So what we'll do today is we'll continue, because we started on arrays already, I think, the other day. Is that right? No? No? Okay. So we'll start on arrays today, and instead of starting from the beginning and talk about the concept of arrays, so we'll basically, I'll assume that you have exposure to arrays in cisp 300 or 301 from before, and we'll start on the actual use of arrays in C and C++. Okay, so that's what we'll do today, is to get a head start on this one. And I will also give you a homework assignment, okay, because this will help you consolidate your understanding of array indexing and stuff like that. Okay, so we'll go ahead and take a look at the homework assignment first. Okay, so this way it will give you a context to understand all of the stuff that we talk about today. So the homework assignment is called reverse, okay, because you're going to do reversal of the input on the string. When you read it from the standard input, you want to reverse it so that it prints out exactly reversed. So the convention is to create a folder first. It is supposed to be called reverse, and make it case sensitive. Okay, write a program in a file called main.cpp, and it has to do the following. So what it does is not complicated. Okay, it's very simple what it's actually doing. Read and process a line. Do it in a loop. So you have to keep doing this until a single line only contains the word quit, Q-U-I-T. And then at that point, you can just exit. You can get out of the loop. Each line of the input may have any number of characters. So I can give you a really short line, like with only one character, or no character at all. Or I can give you a line that has 256 characters. But what you need to do is only to read up to the first 80 characters. Okay, the rest you can just ignore. Okay, read up to the first 80 characters. What you do with the characters that you have read is to reverse all the characters on that one single line and print the reversed text to standard output file. Are we doing okay so far? Okay, I can give you a sample, input and output so that you know what how your program is supposed to behave. So I'll just go ahead and use a text editor for this purpose. Okay, so let's say the input is A, B, C, D, E. Okay, that's the input of the first line. What your program has to do is to print out in standard output the reverse of this string here, E, D, C, B, A. That's what you need to print. If I give you an empty line, you give me an empty line, because the reverse version of an empty line is just an empty line. If I give you a single character like A, you give me a single character like A, because the reversal of one single character is itself. Are we still doing okay so far? Yep, go ahead.
No numbers?
Can be digits, can be anything. Okay, can be punctuations, numbers, letters, uppercase, lowercase. You just have to give it to me, in a reverse order. Okay. Now the trick is, if I give you more than 80 characters, you only have to process and store and reverse the first 80 of those characters. The rest you can just ignore. Am I doing okay so far with that idea? Okay. Okay. So I can give you a line on one particular line. I can give you 200 and something characters. Okay. But what your program needs to do is to only read up to the first 80 characters and process, which means reverse it and print out the reversed version of it. The other characters after the first 80 characters, just ignore, just throw them away. They're not going to be useful. Okay. Are there any questions about what the program is supposed to do? No questions? Okay. So now that I got your attention, with the new homework assignment, we'll go back and talk about the concepts that you need to know to get this done. Okay. So what I'll do is I will go to C string here, because we won't need, okay, we'll start with this one. We'll start with the implementation of arrays, because this is kind of important, kind of to give you a little bit of background information. So the background information is, it will start with the allocation of an array. Okay, so how do you declare an array in C and C++? And the answer is, well, it's just this. Okay, if you want to declare an array of 10 integers and call the array x, this is what you do. Okay, it's just int, which is the type of each element in the array, x, which is the identifier or the name of the array itself, and an open square bracket to indicate this is an array. You put a number inside the square brackets to indicate how many elements you want to have in that particular array. Close the square bracket, and that's it. Okay, that's how you declare and define an array of 10 integers, and you call the array x. This will work, whether x is a global variable or a local variable. Okay, it's basically the same syntax, whether it's local or global. But you do have to be careful when you do something like this, because this is a valid syntax. But in this case, x is really not an array. You are not allocating anything for x. In this case, x is not exactly an empty array either. Okay, x is just a pointer in this case. So this is equivalent to declaring that x is a pointer to an integer. There's no difference between this syntax and int asterisk x semicolon. Okay, those two declarations are basically identical in C. Are there any questions at this point? Okay, I'll give you some sample programs later on, so don't worry. We will definitely see programs that will run with arrays and all the pitfalls that come with the way C implements arrays. So the next section talks about pointers and arrays. The reason why pointers and arrays are in the same section is because in C and C++, a lot of times they are not different. Okay, they are basically the same thing. So we'll go ahead and read the sentences one by one. And C and C++ has a very simplistic way of looking at arrays. The way it works is give me the address of the first element, and then it has a way to indicate or find out the address of every other element using a very simple equation. The equation is b plus I times s. Okay, so in this case, b is the address of the first element, which I would just call it as the base of the entire address. I is the index. It is the index number of a particular element that you want to access. And then s is the size of each element. So given this equation, you can find the address of any element of an array. Okay, you only need to know three things here. B, once again, is the address of the first element, or also known as the address of the entire array. I is the index of the element that you want to access. And then s is the size of each element in the array. Now this little equation or expression works only because all elements in an array must have exactly the same type. And that's why they all have the same size. Okay? Because if that assumption is not valid, then you cannot use this equation anymore, because the size of elements will no longer be uniform. But if you talk about arrays in just about any programming language, they basically want to use the same type of the elements all must have the same type, except for scripting languages because they're slightly different. So that basically explains this particular section here. The only time an array is different from a pointer is when an array of non-zero size is allocated. So that basically is referring to these two lines. Okay, one has a size that has no size specification, like this one here. The other one does have a size specification or number of elements as a specification. So these two are very different. Okay, even though in terms of syntax they are very similar, but in practice, or what they are, they're very different. The first one, as I mentioned a little bit earlier, is no more than just saying that x is a pointer to an integer. Okay, if it is a pointer, where is it pointing to? Who knows? It is not initialized. Okay, so, but the second one is different. The second one, which is y, is saying that y is an array of 10 integers. We know where the array is. We just don't know what the value of the elements are.
10 integers or 10 elements?
Huh?
10 integers or 10 elements?
It's the same here because each element is an integer. So in this case, I can use one or the other. But technically speaking, when you talk about an array, it's better to say that it has 10 elements. and then leave it up to the type here to spell out what is the type of each element. But in this case, because the type of each element is an integer, so that's why sometimes I say there are 10 integers, sometimes I say there are 10 elements, because they're the same thing. Okay. Now in this case, because x is a pointer, you can actually do something like this. Okay, this is a valid syntax. You can basically treat any pointer as the beginning of an array in C and C++, which is actually where most of the problems come from. Okay, most of the problem with C and C++ programming is related to how pointers are used, and in this case, this is valid syntax. Okay, C actually allows you to do something like that. But what this is going to do, or the effect of each statement, is very different. The first one, I'm just going to highlight which one I'm talking about here, is looking at x. Okay, but x as a variable in this case is a pointer. So it's basically saying, okay, x contains an address because it's a pointer, right? And I'm going to assume whatever value is in x right now is a valid pointer. It is a valid address. And that address is the beginning of an array, and in this particular case, I'm accessing the first element of the entire array. Now, can you remind me again what was the assumption? I used assume a few times, okay, in the previous few sentences. So what did I say about what was assumed in this case? I was assuming that x is the address, or x stores the address of an array. What if it is not? If x is not the valid address of an array, this is still going to treat it as if it is. So you will end up with a segmentation fault because you'll be using an uninitialized pointer as if it is a valid pointer. Are we doing okay so far with that concept? The second statement does not do the same thing. The second statement, which is based on the definition of y like this one here, y is not a pointer. Y is the beginning of an array. It is already allocated. It is here somewhere in memory that you can actually access. So it is going to the first element of y and say, okay, let's store a value of 0 into the first element of array y. So in terms of syntax, even though x and y, when they're declared, they look almost the same, and they can be used almost exactly the same too, but the meaning is entirely different whether you are dealing with a pointer or whether you're dealing with an array that has storage already allocated to it. So these two are very different things. Okay. Yep, go ahead.
I'm sorry if you've already hammered this home, but if y bracket 0 is referring to the first cup with a 0 in it,
yep,
what is the x bracket 0 indicating?
Okay, x is a pointer. Okay, remember, when you see int x and then open and close bracket with nothing in between, it's the same thing as saying int asterisk x, which means x is a pointer. It stores an address of an integer. But because it is also a variable, x by itself is a variable, which means what it stores, which is supposed to be the address of an integer, it can be anything. Okay. And as a local variable or a global variable, it starts with an unknown value. So that means x as a local or global variable starts with a just gibberish, right? But the type of that gibberish is a pointer to an integer. So you can do it like this even before x is initialized. But the access to that element will most likely fail because it is not going to be a valid address.
So for the purpose of our assignment, using int x empty brackets is not a good thing.
No, it is. Okay, we'll talk about that. Okay. But once you initialize the pointer, then you can use it as if it is an array. Okay. So these two paragraphs basically just kind of talked about what I talked about a little bit earlier. I'm going to hold off a sample program until I am finished with this entire slide, and I'll give you a sample program. and then go through GDB, then it will really show you what I'm talking about here. Okay. In C and C++, the worst part is there's no bound checking. So ignoring the text at this point, okay, just focusing on the code. This we have seen already, right? This is the same thing as what we saw a little bit earlier. We are declaring that y is an array of 10 integers. So the storage is actually allocated. Y is not a pointer in this case. Y is the starting address of an array of 10 integers. It is existing. Yep.
So those 10 integers in an array, y, what are those called?
Each integer is an array. Is an element of the array.
So would it be like y.1?
It would be y bracket square bracket 0, y square bracket 1, y square bracket 2. It's the same notation as what we use in cisp360. The bracket notation means which element in the array are we accessing. Okay, the problem is you can do something like this, and the compiler does not give you any warning. Does anyone see a problem here? No, it initializes one element to 0, but that element has one problem. Okay, it is only initializing one element to a 0, but that element does not. Yeah, go ahead.
It only goes to 9.
Exactly. Okay, the proper way to use y is to use indexes from 0 to 9. Okay, because we start counting from 0 in C and C++. So the indexes of elements in a particular array is starting from 0. If you have 10 elements in an array, then it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those will be the 10 valid indexes into this particular array. When you use 10 as an index, it is actually trying to address the 11th element of the array, which quote unquote does not exist. Okay? But the compiler does not know, because the compiler actually does not keep track of the size or the number of elements of a particular array. Is that okay so far? So what is that code going to do then? Okay, the compiler does not complain. The linker obviously has no reason to complain either. So what it's going to do? It's going to go to the location right after the end of array y and treat that location as if it is the 11th element of the array.
Even though you define the array as 10 elements?
Yep.
Will it start a second array?
Nope. It's going to eat into something else. It's going to corrupt something that does not belong to y. Okay? And that really is the source of a lot of problems. Okay, I'll explain later on. When we talk about strings, how that is even more of a problem when we're dealing with strings. Okay. Okay. Now this may generate an error, but this certainly will not generate an error. This is the same thing as before, because I initialize I to 10, and then I use I as the index into y. So, but in this case, the compiler has no real way to go back and say that, oh, you're trying to access the same element which does not exist in y. Okay. The rest of this basically talks about what is the program going to do if I really try to access y bracket 10, because it does not exist. So the bottom line is it will just pretend that it does exist and overwrite that location as if it is a part of y. But in reality, it is not a part of y. It can be another variable, can be something else that is also important to the execution of a program. Okay. Now, as to what type of other important things are we keeping track of that is not visible or has no name that we can refer to in C and C++, that's a mystery that we will solve in cisp310. Okay. But that's why cisp310 is useful, because it can help you explain really nasty programs or behaviors of a program that we cannot easily understand in regular C and C++ programming. Okay? All right, so now with all this done, we'll go ahead and, this is the assignment statement for arrays. So if you have two arrays, they're both declared as 10 integers, the normal assignment operation will work. It will copy all 10 elements from one array to the other array. Okay, that actually works. Okay, so that's pretty much the basic introduction to the use of arrays in C and C++. Now this does assume that you already have exposure to the concept of arrays in cisp300 and 301, because I'm not going over the basic concepts of array indexing in this class. Well, partially because we are running out of time, and two, because should have covered in cisp300 already. Okay, so let's go ahead and write some programs. Write some actual code, go through GDB, and find out what's going on here. Okay. Okay, so I'm going to write a fairly simple program first. Okay, so I'll just write a program called I'll call it abuse1, because it is the first one of the many abuse series of programs. The program doesn't really do much. I have one single main subroutine. I don't even bother with other subroutines. I have integer I, okay, and then an array that has, let's just make it have 4 elements, okay. So X is an array of 4 elements. This is declared as an array of 4 elements, and then we have integer J here. And what I'll do is something really, really simple. Okay, what I'll do is to say, let's start some value with I. Doesn't have to be 0. Let's pick something else. Okay, so let's pick 43 here. J starts with another value. Let's pick 71, and then we'll go ahead and initialize X here. I'm not going to deal with X0 to X. Well, maybe we'll do. Okay, so X bracket 0, which is the first element of array X, is going to have a value of 5. I'm just going to do something not too interesting here. Yep, go ahead.
Is there any way to initialize all the values in one command?
When you declare an array, you can start with initialize values, but other than that, there are no simple ways to initialize the entire array with a particular value. There's a way to do it using memcopy, but we're not gonna touch on that right now. Okay. And this is the problematic one. Okay, this is the problematic one, and it's going to say, let's pick something that's somewhat unique, 93. Okay, and then return 0. All right. So this program, the compiler will definitely complain about it, because I am initializing elements in X, but without using it for any purpose. So let's go ahead and just convince the compiler that yes, we are doing something using it. Don't complain. Stop screaming. So we'll just go ahead and say std cout, and let's print X bracket 0. Okay, that's all we need to do to shut up the compiler. Okay, there we go. So fairly simple program, right? I and J are still not used to, but we'll just ignore those warnings, in this case. Okay, G++, -1 all. We know it's going to warn about that one. Then take -G, because we will run this program in GDB. -O abuse1 abuse1.cpp. So it does complain about I and J, but we kind of know about this one already. It's nothing new. We'll now GDB the program, abuse1. List the program, put a breakpoint on line 8, which is the first line that actually does anything. Run the program. We're now on line 8. Print I. This is before we run it. After we run it, I has a value of 43. Okay. Single step. So print J first. J is uninitialized at this point. Single step. Now J has a value of 71. So right now the program is doing everything kind of as expected, nothing new, right? And GDB is really nice because you can actually say print X, and what it does with print X is it will print out all the values, all the elements in X in one single shot. So in this case, it's telling me that the first element has a value of 0, the second element has a value of, let's see here, 134 million something. The third element has a value of 1. The last element has a value of negative something something. Okay, okay, nothing really surprising because it is uninitialized at this point. So I'm going to go through all of these instructions to initialize all the elements in X, and now it has the values of 5, 7, 1, 3, which is kind of what you expect. Okay, are there any questions at this point? No questions? Okay, so I'll just kind of confirm again what is I. and what is j. So everything is just the way they are supposed to be at this point. Now we run the last instruction here. This is the problem, right? Because the array only has 4 elements. The indexes should only go from 0 to 3. So now that I use an index of 4, it's going to be a problem. Oh, by the way, did the compiler complain about this? Nope. The only complaint that I got was I and j were initialized but not used. It did not complain a single time about how I used the array. So let's single step it, okay? No problem, Tag, you lied. You said there would be a problem. There's no problem, right? Let's go back and check on I and j again, okay? What? But I and j have nothing to do with the array x. I is fine. J, what was j supposed to be? 71, and it's now 93. Who was supposed to be 91? 93.
No, the element of your
X bracket 4, right? X open bracket 4, close bracket. It's supposed to be 93. What is going on here?
it overrode.
You overwrote, exactly. So basically what happens is in memory, the way memory is allocated from the compiler's perspective is it will just allocate things, in the order that they appear. So the first thing that it will allocate would be for local variable I, and then the 4 integers in x, and then the 1 integer in j, right? So the order is going to be I, x bracket 0, x bracket 1, x bracket 2, x bracket 3, and then j. Is that making any sense? It's just a sequential order, right? So when x bracket 4 is supposed to be the 5th element in x, it is actually overlapping with j.
Why not I?
Because I is before. Okay, now we already know the ampersand operator, right? It takes the address of something, right? Let's take a look at the address of I. Okay, let's take the address of x bracket 0. You can actually take an address of an element, that's fine. That's off by how many bytes? It's actually off by, it's off by more than 20, it's actually off by 20 bytes. Okay, x bracket 1, x bracket 2, those are all sequential, right? 3, 4, and that's the one that is a problem, right? This one is not supposed to exist. X bracket 4 does not exist. What about j? J has the same address as x bracket 4. That's why we have a problem. So the way the compiler organizes data is it looks like it's allocating for the array first, and then it will allocate for j and then allocate for I. But that's up to the compiler to decide how it's doing the memory allocation. But the main point is if you access an array out of bound, out of the allocated number of elements, it would chew up something else. And what it chews up can be another variable, like in this case. But it can be worse than that. Okay, I'm not going to go really deep into how big of a problem we can get into when you access an array out of bound. Okay. Are there any questions at this point about how to use an array in C and C++? No particular questions? Okay. So if there are no particular questions, we'll move on to the next topic. And I will skip pointer arithmetic at this point. We'll come back and deal with it because it is an important topic. But we'll skip to C strings right away because it is directly related to your homework assignment. And it will also help illustrate how to use array indexing in C and C++. A string in C is an array of characters. Okay, so it's basically, this is a string. It is just an array of 32 characters in this case. But this array can only store up to 31 actual characters as its content. Okay, and the reason why is because we use up one character in this entire array as the terminator, the terminating character, which is also known as the null character, which has an ASCII code of 0. So that's why when you declare an array of 32 characters, you really can only store up to 31 character as its content, because there's always one that is acting as a terminator that always has to have the ASCII code of 0. Yep.
So in your example that you just did, 5 was your terminating value?
No, but with integers it doesn't apply. It's only when you have an array of characters and you want to use it as a string, then this convention applies. You have to use a null terminator to indicate where a string ends. Okay. So we'll do some actual sample code here. If you want to read from an input file into a string, it's pretty easy. Okay, we can use the same right shift operator and say cin into string, and string is defined like this, and it's going to read something from standard in into the string. But there's one problem with this approach. The problem with this approach is it will stop as soon as it sees a space character. So that means it's not going to read in the entire line. It's only going to read in as much as it can up to the first space character, and then also line feed characters. So let's go ahead and test this one. Okay, this is a good way to test the program, and that's also a good way to kind of look at what kind of problem you can get into when you read something more than what the string can actually store. So we'll go ahead and write a separate program, and we'll call that abuse2 because it is also an abuse of an array. So this time we'll allocate a character array. So each element is a char as a character, and we'll call it str. Instead of making it 80 characters or 60 or 32, we'll just make it 4. It doesn't really matter how long it is. It is already sufficient to illustrate what I want to demonstrate. And we'll do a pound include IO stream so that we can use cin. Yep, go ahead.
So is there a limit on how big your array can be?
Practically, really no. Okay, you can make an array that is really large, but typically when you're dealing with a really large array, then you're also using a lot of resources on the stack, which is a limited amount of resource. So you don't want to declare arrays much larger than what you really need. Okay. So I'm going to read into str here and return to 0 at the end. That's it. That's my entire program. It doesn't do a whole lot, but it's already enough to illustrate, well, I would say quite a few things. Okay, so we'll go ahead and just go ahead and take a look at this program and see what kind of nasty things we can get into here. And we're going to have some more fun here. We'll have I and j, and we'll go ahead and initialize I to, I don't know, 17, and initialize j to 23. And we'll do something fun with this program and see what happens. Okay. So G++, -1 all pedantic. It's going to complain again because I have I and j initialized but not really used. -G for debugging. -O to specify the executable output name. Oops. And then we have to specify the input, which is abuse.cpp. Oh, okay, it's complaining. Yeah, std. No. Okay, this time it only complains about I and j. They are set, which means they're initialized but not used because they're not read anywhere. That's fine. We'll go ahead and also create a file called test.in, which is our test input file. So the test input file is going to have AB and then a space character, DE, and then G, A, B, C, D, E, F, G, like so. So that's one single line right there. Okay, the first two characters are AB, a space character, DE, and then a space character, and then FG, and then end of line. Okay. So now we can go ahead and test our program, which is abuse2. And we'll run the program using the redirection symbol. In other words, even in GDB, you can redirect standard input from a particular file. But in this case, it's really helpful to do it this way, because this way, you're not gonna, it won't interfere with the actual commands to GDB this way. Okay, so we'll read it from test.in. Oh wait, I need to set up some breakpoints first. So let's set a breakpoint on line 7, and then run the program redirecting standard input from test.in. And now we're on line 7. Okay, line 7, single step, single step. I is now 17, J is now 23. Nothing really surprising, right? Okay, so far so good. And then we'll go into cin, here. I cannot step into cin because if I step into it, it will go into the actual code of the right shift character. So instead what I'll do is I'm going to put a breakpoint on line 10 and just run the program continuously at this point because I don't want to step into the whole mechanism of cin. Okay, so now that we're done with the cin line, content is now read into str. What do you think is read into str? Remember?
AB breakpoint, the space.
AB and then the space, and then do we? What about the no character, the terminator? Remember, in C, the standard is in order to indicate this is the end of the content of the string, you have a no terminator.
You also said that there's a problem when it reads a space. That's why.
It won't read the space. The space is what is separating AB from DE. Okay, but it still needs a no terminator after AB. So, okay, let's check it. Let's find out what it is. Okay, so we can print I, we can print J. They're still the same. Nothing really happened to these two. We can print our str, the string, and this is what it is. It shows you that it has the content of A, the ASCII code A, the ASCII code of B, and then the \000 is our no terminator. In other words, it uses up one character to basically say, this is the end of the actual content of the string. Because otherwise, there's no easy way to tell, okay, which part of the string is the actual content that I read from standard in. Is that okay so far? The concept of using a no terminator as a marker to basically say, this is the end of the content that was read. Because otherwise, an array of 4 characters is always an array of 4 characters. Which ones of the 4 characters were the ones that I read back from standard in? There's no way to tell. But now that I use a no terminator, I can tell. Is that okay? All right. Yep.
So how do you use the null terminator? Just put a space in between, and that's how it brought in the null?
The convention is, the content of str as a string is only the content before you encounter the no terminator. So in this case, because the no terminator is the 3rd character in the array, that means only the 1st and the 2nd character is the actual content, which is what we read from standard in.
Okay, so the question was, how did you put in the null?
It's done by the reading convention, does that automatically. So
Oh, it does automatically. Okay.
the right shifted operator, it actually does it.
Oh, okay.
Okay. Is that okay so far? Yep, go ahead.
So looking at your print string, AB was the first 2 characters read into your file.
Right?
And everything after that is
It's not read.
it's not
It's
read.
still in standard in. It's on the conveyor belt. Nobody has bothered to move anything else out of the conveyor belt.
So the D and E, the space, and the F and G have not been read into your program at this point.
That is correct. Okay. All right. So this is okay. I can continue execution. Nothing bad is going to happen in this case. So okay, fine. Let's go ahead and create another test file. So this time I have A, B, C, D, E, F, G, space, and then 1, 2, 3, 4. Fine. Okay. So this is going to be a problem, isn't it? Because remember, cin is going to read everything into the string up to but excluding the first space character. So in this particular case, it will read A, B, C, D, E, F, G, H, 8 characters into str, the string. But how many characters do we allocate?
4.
We only allocated for 4. So where are these other characters going? Remember, there are 5 characters that are not accounted for at this point, because there's E, F, G, H that we already know, and then there's the no terminator that also has to go somewhere else. So all of that stuff has to go somewhere, okay? The question is, where is it going? So let's go ahead and debug the program and find out. So I'm not going to put a breakpoint on, well, we'll put a breakpoint on line 9 just to check if I and j are properly initialized, and then put a breakpoint on line 10, okay, just so that we can continue to execute after the cin. And this time we'll run it redirecting from test1.in, which is the one that has a longer initial portion. And we'll stop on line 9 just so that we can check I and j are properly initialized. At this point, we do a continue, it will stop on line 10. And it doesn't crash, okay? That's the worst part, is it does not crash where the problem is. Instead, it will do something nasty so that the program may crash later on. So now the question is, what is in I? Oh, what is in j? What the? Overrode it. Now the question is, maybe something else went wrong with the program and then the I and j got corrupted. Well, there's one way to double check and see what is actually in j. Let's print j in hexadecimal and see what we see. Do you see any type of regularity here? 6.8, 6.7, 6x, and 6.5? Does it look like a random corruption to you? Not at all, right? There's a pattern to it, right? And do you think those patterns have anything to do with the content of the input file? What do you think is the ASCII code of E in hexadecimal? Okay, let's check, okay? Because I think this is something that will be slightly illuminating. If you just do a man ASCII in Linux, it will show you the ASCII table. And we just want to look up the ASCII code of lowercase e, which is this guy here. You see 6.5, 6.6, 6.7, 6.8. In other words, when we try to read 9 characters into an array that only had 4 characters allocated, the other 5 characters are stored somewhere. Except it's not, stored in the array because we only had 4 characters in the array. It overrode the other variables. Is that okay so far? Okay. Now this is a huge problem in C and C++ programming because a lot of programs have to do with strings, okay? And the problem now is, okay, if you're dealing with strings, you better know how many characters you should be reading. Okay, before you just say, okay, give me a string. Well, the string that you're reading in may be larger than what you have allocated to store the string. So now we have a problem. Okay. Okay, so that's the first issue that we have to deal with. But according to the homework assignment description, we're supposed to read it in the entire line and then reverse the entire line, right? And this is going to read in something up to the first space. So now we have 2 problems instead of 1. Well, guess what? The next thing is going to solve both problems in one single shot. It's one stone that will kill 2 birds. It's called getLine. It's a method of cin. So the way you use a method for a particular object is you name the object. In this case, it's called cin, which is the good old cin that we already know have used here before. And then you specify a dot, which means apostrophe s. It's kind of the same thing as a structure because an object is basically has a type of a class which is very similar or close to a structure. And in this case, I'm not accessing a particular member attribute, we're accessing a method, and the method is called getLine. You can kind of look at the first part as the name of a subroutine itself. It sort of is like a subroutine. And then we can pass parameters to it. The first parameter to getLine is a character array. In other words, you are telling getLine where to store the content that you're reading in. The second parameter is the most important one. The second parameter specifies how many characters do we want to read. This is the maximum number of characters to read into str in this case. So in this case, I'm just saying, okay, even if the line has a gazillion characters, read only up to 31 characters into str. So using this convention, I don't have the problem that I experienced earlier anymore, because now I'm saying Even if the line is longer, has more characters, then I can store only read up to 31 because I have an array that only has 32 characters allocated. Yes?
Getline will also take care of the space.
Yes, because it's reading the entire line, and that's what the third parameter is for. The third parameter lets you specify what is considered the end of a line. So the convention is to use the line feed character, \n, to indicate the end of a line. So that will take care of reading an entire line instead of reading just the word and then the space.
So with your example of A, B, C, D, E, F, G, H, space, 1, 2, 3, 4, it's going to read everything up until the end line, but it's only going to store the first four elements.
Yep, exactly. Okay, so let's check to see whether that is what it's supposed to do. Okay, so we'll go ahead and change the program. Okay, so you can definitely see the problem of accessing an array out of bound, because it would just overwrite something. Now we are kind of lucky that it overwrote only variables. Okay, because there's a potential thing that it can do to overwrite something that is not visible to a C program at all. And it will change the way a C program executes in very, very strange ways. Okay, I'm not going to get into what kind of strange problem you can get into when you corrupt things other than just other variables. Okay, but it can be very mysterious. We talked about that in cisp360, which is the next class that you can potentially take after this one. All right, so let's go ahead and just look at getline. Getline is not a difficult thing to do. I will stream, and we'll just use basically the same code as last time, but this time I'm going to use, I have no need to use INJ anymore this time, so I'm just going to do a regular cin, declare an array, str, let's say only 4 characters, and then we'll do a standard cin into, oops, not right shift anymore, this time we're using getline. The first parameter specifies where we are going to store the characters that we are reading in. The second one specifies the number of characters up to this many. We're reading up to this many characters, so we're reading up to 3 characters. And we are going to use the line feed character as the end of line character. We'll return 0 here, and then we'll go ahead and test it. And it's complaining up to instead of 1, sure. Okay, GDB, getline, and we'll run it from test1.in, which is the one that has a long line. I mean, there's a lot of stuff going on in that line. Oh, we have to set a breakpoint, otherwise we can't see anything. So we'll put a breakpoint on line 7. And then we'll run the program redirecting the standard input from test1.in. Now we're on line 7. We can go ahead and print what is str. But before I print it, what do you think it should be? The content of test1.in is A, B, C, D, E, F, G, H, I think, and then the space, and then 1, 2, 3, 4, 5. So what do you think should be in str at this point? And then the no terminator. The line feed character is tossed away. It doesn't actually put it into the string, but the no terminator should be there because it marks the end of the content. Okay. And it is reading in just AB is not. That is unexpected. I think I know why. Because this number is actually indicating what is the size of the array, so it already took that no terminator into consideration. Okay. Do one more time. I have to change my notes as well. Okay, so we'll ask it to read 4. Now this is not asking it to read 4 characters, it's telling it that the buffer or string has a size of 4. So effectively it can only read 3 characters. breakpoint on line 7, run, redirecting the input, print str, and it has ABC. Now the null terminator is implied here, it is actually there, okay? Because if you print str as individual bytes or individual characters, it will show it. str0, str1, str2, and here's str3 as the null terminator. So are there any questions at this point about how to use getLine and how to use it in your program? Yep.
Within the program, in getLine, when you do parameters, you have where it's reading into and then how many it's reading into. Could you put the number of things you would like it to read? So like if I wanted to ABC, I would write 3, and then for the null character, just put +1. Would that work?
Not quite sure what you're asking though. Where are you putting the +1?
The +1 is within the section where you put 4 this time because you wanted it to read 3 characters.
Right, but you have to allocate, remember you have to allocate for storing that null terminator as well.
Yeah, so instead of adding 1 actually into it, could you put 3 + 1 in the space where you put 4?
Yeah, absolutely. You can be, that part can be any expression that evaluates to an integer. So you can have a constant, or you can have a huge long expression to specify how many characters is allocated in the string.
Okay.
That's basically what the parameter is how big of a string you have allocated. Yep. All right, so I think that should take care of one part of your homework assignment, okay? So the second part of the assignment is, okay, I need to know that I have just read quit, Q-U-I-T, right? So how do we do that? Well, okay, I'm going to modify this program to show you one way of doing it, which is not really the best way to do it, but it is workable, okay? Oops, getLine.cpp. So if I want to know whether I have just read ABC, I can do something like this, right? I can say, okay, str0 is that A, and str1 is that B, and str2 is that C. So we can kind of imagine they can spell out the quit, and say compare the first character, second character, third, and fourth character to Q, U, I, T, and if the conjunction is true, that means you have just read something that starts with Q, U, I, T, so you better check the fifth character being a null terminator, just to make sure that you're not reading in quitting, okay, because I said, quit, not quitting, or any other variation of quit. Okay, so that will work. Okay, this expression will tell you whether I have just read ABC, but in this case, remember what I said? If you want to read just ABC and not ABCD, then you better make sure that the fourth element is a null terminator, and a null terminator is just a 0, so you can just compare to 0. Okay. So let's say this is 40, and this is also 40. Then we can actually process ABC, right? Okay, so let's go ahead and test this program and see whether it can correctly check whether I have typed in ABC or not. ABC all by itself cannot be ABC and then followed by something. Okay. And for this, we'll have a test2.in, which is just ABC all by itself on the line. There we go. All right, so let's go ahead and recompile the program. Oops. Recompile the program. And then gdb getLine again. And this time I can just run it without stopping. So I'll just run it with test2.in. And if it is correct, it will give me a return code of non-zero. The program should have an exit code of non-zero. And it has a return code of 01, which is non-zero. That's great. Let's give it a file that does not end with ABC, or does not have ABC on the first line. And that would be test1.in, and this time it said it exited normally. When it says it has exited normally, it means it has a return code of 0. Okay, so that logic works. Okay, that's one way to do it. But if I want to test, if I want you to compare a string to a longer string, that method gets pretty tedious, right? So it would be nice if we have a subroutine that can just compare two strings and tell us whether the two strings are the same or not. Is that making any sense? Okay. So we'll go ahead and take a look at how to do that. Now the nice thing is there's a function like that already. It's called string compare. String compare has two forms. One form is just string compare without the n, and you give it string 1, you give it string 2, it will return an integer. Now you can see that your string compare does not say greater than, less than, or equal to, because the return value indicates that. The return value returns an integer that is less than equal to or greater than 0, depending on how string 1 and string 2 relate. If string 1 is greater than string 2, it returns a 1. If string 1 and string 2 are the same, it returns a 0. If string 1 is less than string 2, it returns a -1. Are we doing okay so far with the return value convention? Now when you compare two strings, what does it mean when string 1 is less than string 2? Can someone tell me what it means to have a string 1 being less than another string? Numbers we understand, but what about strings?
Less characters.
Okay. So if I compare X, Y, Z to A, B, C, D, E, F, G, which one is less?
X, Y, Z.
Nope.
Because the ASCII codes of A, B, C.
Yep. It's the lexical ordering of the strings. It means if you look up a word in a dictionary, if it appears on an earlier page, then that word is quote unquote less than another word that is on the later page. So X, Y, Z is considered to be greater than A, B, C, D, E, F, G, because X, the ASCII code of X, is greater than the ASCII code of A. So the ordering of a string depends on the ordering of individual characters. What about ABC versus ABC? They're the same because they're all exactly the same. What about ABC versus ABCD?
ABCD is greater than ABC.
That is correct, because the D is actually compared to the null terminator of ABC. Well, that's one way to look at it. All right, so, yep, go ahead.
But in the assignment is asking us to reverse it.
Yep.
So what if someone were to type in PIUQ? Reversing that spells out QUIT.
If the input is not QUIT, you just process it. You will print quit, but you're not going to actually exit out of the program. It has to be the input being QUIT that you exit out before the processing. That's a good question. I like it. Okay. All right. So what we'll do for the next about 15 minutes or so is to implement some of these string functions. Okay. That part is actually here. And there's a little section about string processing is the root of all evil. Well, not exactly all, but a lot of it. Because of the improper use of string processing, that's why we have a lot of exploits. Okay, a lot of the exploits that we have seen or heard about, they're all about not processing strings correctly. Okay, because you guys saw what happened, right? You saw how our variable I and j got corrupted when we attempted to read 9 characters into an array that only has 4 characters allocated. And if you extend that approach a little bit more, you can now actually start to write exploits to break into programs, break into computer systems. Okay, so this section talks about common subroutines that the standard C library supports to perform compare and also copy. I'll finish both of these subroutines. Okay, they're fairly simple to implement. The first one that I'm going to implement right now is string compare. String compare is comparing string A to string B, returns -1 if string A is less than string B, returns a 0 if they're the same, returns a 1 if string A is greater than string B. So let's go ahead and see how we can do that using array indexing operations. So I'll just call this string compare because I'm implementing that myself. So I'll do an integer here. Okay, let's pound include IO stream. and we'll implement our own subroutine. Okay, so I follow exactly the same convention as string compare, except this is my own string compare. So I'm going to call it a text string compare, just so that it's not going to be the same. Const char string A, const char string strb. And the reason why I use const here is because you should not be modifying the strings if you're just comparing. And that's why I use the word const here to remind the compiler and say that if I have any code inside this subroutine that changes what STRA points to, don't let me pass. Okay, give me an error message and say that, oh, you're not supposed to change the strings, that you're supposed to be just comparing. Is that okay so far? Now, I could have written the subroutine without the const. It would still work, right? But if I accidentally put in any code that changes the content of the string, the compiler would not be able to catch me in that case. So I want the compiler to be able to catch me as much as possible so that I don't have problems like that. I have a local variable called result to store whether I should be returning a -1, a 0, or a 1. And to do that, okay, so the last statement is easy. Okay, I'm just going to return result here. Okay, what do I do here? So you have to kind of think about how to compare a string. If someone gives me ABC versus ABCD, then I'll be comparing the A versus the A, the B versus the B, C versus the C, and then one string would have the null terminator, the other one would have D, and the null terminator is less than the ASCII code of D, then I know there's a difference, and I know exactly how they're different, and I can return the code that I'm supposed to return. So what do I need here? Conditional statement or loop? Am I doing something repetitively?
Yeah.
Okay, so we'll do a loop here. Okay, so we'll do a loop, and the way I do a loop is I just put in the construct of a loop, and then I'll worry about what I need to do, to get out of the loop here. Okay, when should I stay in the loop? Okay, so let's go ahead and evolve this program, step by step. Okay, so I'm going to use comment here. I want to stay in the loop as long as nothing can be concluded. Stay in the loop. Does that make any sense? Because the only reason I'll be getting out of this loop is, oh, okay, I know how these strings are ordered, so now I know what result I should be returning. It's time to get out of the loop. But I need to stay in the loop as long as both strings are exactly the same. Is that making any sense? Kind of? Okay. But I need a way to keep track of which character I'm comparing in each string. And remember, every pointer can be seen as an array. Okay? So this is what I'll do that is directly related to your homework assignment in terms of concepts. I'm going to have an integer I. It's conventional to use I as an index, because I is the first letter of index. Okay. So what I can do is to say, you know what, if the element at I of string A is the same as the element I of string B, using I as indexes in both cases, I should stay in the loop because I cannot make any conclusions yet. Okay. But hold on a second here. If they are both zeros, or if one of them is a 0, I should get out. Because what is a 0? What does a 0 mean? If STRA bracket I is a 0, what does it mean?
Well,
That's the end of that string, because it's a null terminator. Okay, so maybe I should check for that too. So as long as they are the same and not terminated, then I should continue with the testing. Okay. And how do I express the second condition? That I'm not seeing the end of string. If I see the end of string, it is a 0, so that means
STRA bracket 0, STRA B bracket 0.
no, I can just check one of them because they're the same. Okay, so let me explain this part a little bit here, and I'm going to get rid of the comments. Okay, so the first part of the left-hand side of the conjunction says, STRA at this character position and STRB at the same character position are exactly the same. Okay, well, I cannot tell they're different at this point. But I also need the second condition to be true to stay in the loop, because the second condition means STRA at position I is not a null terminator. It has not ended yet. Okay, hold on a second here. So don't we also need to check STRB to make sure it has not terminated yet? But they're the same, exactly, because of the conjunction. Okay, I would not be comparing to 0 unless the two characters or the characters at the same position of the two strings are the same to begin with. So I only have to check one of them to know that, oh, okay, we are not at the end of either one. Is that okay? Okay. And what do we do in the loop here? Everything up to this point is exactly the same. How should I move on to the next iteration? I just need to go to the next character, right? To go to the next character, I plus equal to 1 plus I guess I plus 1. Take your pick. That's all we need to do. Okay, great. But when we exit, result is still uninitialized, right? So how do I determine what value I'm supposed to be returning here? Okay, I'm going to do it the long way first. If we have enough time, we'll do it the short way. Okay. So I'll just go ahead and do it something like this. Okay, else if blah blah, that else blah blah. Okay. So I'm going to say sometimes result needs to be 1. Sometimes result needs to be -1, and sometimes result needs to be 0. In other words, I'm outlining the structure of the conditional statement, and then go back to you to basically specify under what condition I'm supposed to return a 1. Okay, we're supposed to return a 1 when string A is greater than string B. How do I know that string A is greater than string B? The last character that we compare in the loop is the one that got us out of the loop, right? So the only way I can get out of the loop is either the character at position I of string A and the character at position I of string B are different, okay? So if they're not equal to, I don't even bother to check whether one is a null terminator, and I get out, right? So if I got out because of that reason, then I can just say, oh, then I'll just compare that, right? If STRA bracket I is greater than STRB bracket I, then I'm supposed to return a 1. Is that okay? So if you're comparing A, B, C versus A, B, D, then A and A are the same. Okay, next iteration, B and B are the same, and then in the next iteration we're comparing C and D. They are not the same. We get out of the loop. But after we get out of the loop, I will still be the index of the C of the first string and the D of the second string. So at that time we can say, okay, let's compare those two characters to determine what value we're supposed to return. So the second one is going to be about the same, except it is the opposite, right? Like that. And if it is not greater than, it's not less than, they must be equal to. If they're equal to, we can return to 0. Is that okay? So that's how we can write string compare. Let's see. The string compare is useful, but now we run into another problem. Okay, we run into the same problem as last time, which is if a string. Okay, this is what we are dealing with here. Let me illustrate it using a text editor. So let's get this out of the way. And okay, so let's say we have a string declared like this. It's a string of 4 characters, an array of 4 characters. And I do it like this. And we'll just copy it a few times, like that. 1, 2, 3, Just to make it more interesting, we'll just make it A, B, C, D. Okay, fine. So what do you think is going to happen when I compare this string with another string?
The same string?
Well, let's compare to a different string that has 5 characters. So let's compare to string B. No, another string of the only of 4 characters will be fine. So let's call this 0. And they have exactly the same first 4 characters. Okay, so in this case, if I say what is the result of string compare str0, what is the result?
0.
Are you sure?
Yes.
But the proper answer is we don't know what it's going to return. Now, why is that? It compares A to A, right? The first element, fine. Second element, B to B, fine, no problem. C to C, no problem. D to D, no problem. Are we getting out of the loop?
No.
We're not getting out of the loop because I have not seen the no terminator yet. And I'm not seeing any differences yet, right? So what I'll be doing next is to compare str bracket 4 to str0 bracket 4. Why is that?
Out of bounds.
They do not exist, right? So I'm gonna take a peek into another variable, and I don't even know which variable because it depends on how the compiler allocates the storage of the variables. So I'm gonna take a peek into a character of another variable for str, and I'll do the same thing with str0. And then I use those 2 bytes to compare. Do I know at this point what I'll be comparing?
No.
Absolutely no idea. Okay, so that's the problem with str, or the way the C represents strings, is you can run into problems like that. So in this case, it will be nice if I can just say, you know what, even if you don't see the no terminator, only compare up to 4 characters. Stop after comparing 4 characters, even if you do not spot the no terminator. Is that okay? And that's the end version of str compare. So when you look up the man pages, okay, I'm just gonna save this first. But when you look up the man pages of CMP, strcmp, which is string compare, you see there are 2 versions. One is string compare itself, which only has 2 parameters, string 1 and string 2. The second one is what I would call the N version of it. The N version has an N in between, str and cmp. And you can see that it has 3 parameters instead of 2. It still has string 1, the first string, the second string is s2, and it has a 3rd parameter, which is n. The n here, or the 3rd parameter, specifies and say, okay, if I do not see the no terminator in either string 1 or string 2, I will only compare up to n characters anyway. And that is what we'll use, for your, for most string functions. We are running out of time, but I can tell you that string copy has the same thing. But this part is kind of important, so I'll do this, and then we'll have the end of the class. String compare is usually relatively harmless because you're only comparing. You're not destroying anything. You're not overwriting anything. So even if it comes to the wrong conclusion, it's not going to do any memory corruption by itself because you're just reading, some location that you're not supposed to read. You're not changing. But string copy does, okay? Because what string copy does is it copies source to destination. So if the source does not specify a no terminator, then you're going to keep copying until you find a no terminator, which can be a long way from where you start. And you'll be running out of space at the destination and not know that you run out of space in a destination, and therefore overwriting a lot of useful stuff that belongs to somebody else. Is that making any sense? So string and copy is basically saying, okay, we'll copy from source to destination, but only up to n characters. After n characters, we just stop. Yep.
So the n characters in our comparison, so like in our homework, you want us to work with the first 80 characters. So
Correct.
So it'll be 80 or 79.
It'll be, but you're not going to use string copy, or if you use string copy, you have to work with up to 80 characters. Okay, so you kind of have to think about that one. The one thing that I do want to emphasize is the difference looks kind of small, string compare versus string and compare, but a lot of computer security issue has to do with the choice between these two. Making the wrong choice using string copy instead of string and copy is the source of a lot of serious computer security issues that have happened in the past. It's called a Stack Overflow exploit. You can look up the term, okay, and find out exactly what it is and how frequently people run into those kinds of security issues. And it's just that, just a choice, okay? You want the end version or the not end version, and that can make a huge difference in terms of computer security. All right, so I'm going to end today's lecture here, and then next time, we'll continue. And you might want to get started with the homework assignment, because the way we already have enough stuff to read in the lines, okay, and you already have exposure to string copy, which is also what you need in order to copy the string before you reverse it, okay. So if you can just kind of echo back the line the way it is without reversing by Wednesday, you have a head start. So I would definitely at least get that part done before Wednesday.